All right, here we are in Unit 2A. We're going to go over the practice tests so we can all dominate the test this week. So either Tuesday through Thursday, depending on who your teacher is. So let's look at this as we go through. So I'm going to skip questions 1 through 5 because that should just be you going through your notes and writing out all of those different trig identities. Okay, you really need to know those. The only ones that we are going to give you are the sum and difference formulas. So you better make sure that you have the other ones either memorized or know how to derive them from different formulas that we've used in class. Okay, so I'm going to start with question 6 and just go through a lot of these trig proofs. So I'm going to go through this fast, so definitely, like, if you get confused, pause the video, kind of think about where I'm getting certain things. Okay, so again, like always, we have our imaginary line that we cannot cross at any time. So we always have a choice of like which side to work on. So this side seems a little more complicated, so I'm going to pick the left side. All right, now I can see up here I need a sine x minus 1. You always focus on the end to be like, what is my end goal? Okay, so if sine x minus 1 is the end goal here, well, I have a sine squared x minus 1, so I could factor that out. So here's sine x cosine x plus cosine x minus 2 sine x minus 2 all over sine x minus 1 times sine x plus 1. Okay, so because this is a difference of squares right here. So I have sine x minus 1 and sine x plus 1. Well, I want sine x minus 1, so the goal now is to be able to cancel out this. So I must be able to do that somewhere up here. Okay, now up here we have the first two terms have a cosine in common. The second two terms have a negative 2 in common. So I can group these and factor it by grouping. So here's cosine x times sine x plus 1 minus 2 times, pull out the negative 2, and I'm left with sine x plus 1 all over sine x minus 1, sine x plus 1. All right. Okay, so I can pull out a sine x plus 1 from both of those. So I get sine x plus 1 times cosine x minus 2 all over sine x minus 1 and sine x plus 1. All right, well, sine x plus 1 and sine x plus 1 both cancel out, and I'm left with cosine x minus 2 all over sine x minus 1. And that is exactly what I wanted. All right, so it's definitely just looking through and really kind of playing around with it to be able to figure out where you're going to be going. And don't be afraid to try things that may not work. Okay, you can always go back and be like, okay, I need a different strategy going through this. All right, so here's question 7. So here we have sine theta plus sine of 2 theta. All right, so we always want things in terms of theta. I don't want a 2 theta over here. So whenever you're given that, we need to get our double angle formula so we can just get it in terms of theta. Okay, so here's sine of theta plus, now the sine of 2 theta is 2 sine theta cosine theta all over 1 plus cosine theta plus cosine of 2 theta. Again, I don't want this 2 there anymore. So this will end up being cosine squared theta minus sine squared theta. All right, now the goal is tangent. So tangent equals sine over cosine. Okay, so I don't want sine in my denominator. So if I actually can rewrite this, here's sine of theta plus 2 sine theta cosine theta I can actually rewrite this so it looks like 1 minus sine squared theta plus cosine theta plus cosine squared theta. Okay. Ooh. Well, I have 1 minus sine squared, that's cosine squared. And also at the top, I see that I have a sine here and a sine here, so I can factor out the top. Sine theta equals 1 plus 2 cosine theta. All right, and this is cosine squared theta plus cosine theta plus cosine squared theta. All right, so I'm going to actually bring this up over here now, just to get a little more room. Well, the top's factored, so that's sine theta times 1 plus 2 cosine theta all over. Well, now I can factor the bottom. All of these have a cosine, and here that I'm going to get 2 cosine squared theta plus cosine theta. And like I just said, now we can factor it out. 1 plus 2 cosine theta all over cosine theta over 2 cosine theta plus 1. And hey, look, these all cancel out, and I'm left with sine theta over cosine theta. And that's what I wanted. All right, awesome. So do remember, like, if you've been struggling with these, treat it just in terms of sines and cosines. Okay, it might make your life a whole lot easier. That way you have to remember less things, you have to work with less things. So if you can just do it in terms of sine and cosine, your life might be better. Okay, so let's try that tactic over here. So again, I have 1 minus cosine over sine minus sine of negative theta over 1 minus cosine theta equals 2 cosecant theta. So again, this cosecant is equal to 2 1 over sine of theta. Okay, so I basically at the end want 2 over the sine of theta. Okay, all right, so now I'm going to kind of go through here. Again, I just want theta, so the fact that this is a negative theta, I got to be able to bring that negative out because sine is an odd function. So 1 minus cosine theta over sine of theta. Now this will be plus, because the negative comes out and I get a negative negative, which means positive sine theta over 1 minus cosine theta. All right, now, again, looking at the end goal is to just get 2 over sine. So there are no cosines over here. So I want to try and get rid of this. So the only way I can convert cosine to sine is if I have a difference of squares, and it's 1 minus cosine squared. So I can multiply this by the conjugate over 1 plus cosine theta. Okay, and so I get 1 minus cosine of theta over sine of theta plus, this will be sine times 1 plus cosine theta all over 1 minus cosine squared theta. All right, so cosine squared is sine squared, so this is 1 minus cosine theta over sine theta plus, I'm going to multiply this out, sine theta plus sine theta cosine theta. I'm going to convert this to sine squared theta. Okay. Oh, I actually made my life a little harder. So sometimes you actually can see that, like, oh, maybe I didn't need to multiply this out because sine over sine squared would just be 1 over sine. So all of these have a sine, so I can cancel that out. So that's why, again, like, you're going to make little mistakes. You're going to do things that are unnecessary at times. You just have to learn to kind of go with it to understand where your end goal is. So So here I have 1 minus cosine over sine plus, here I'm left with 1 plus cosine over sine. Okay. And we'll end up in plus, just double checking that everything is a-okay. Because, oh, yes, everything is fine. Okay, so just double checking that everything is working okay. All right, so now these have common denominators, so I can add them together. So this gives me 2 minus cosine plus cosine. Well, those go away, so I'm left with 2 over sine of theta. And I'm good to go. All right. So see, like every now and then, do take a step back. Do try and go through to figure out what needs to be done. Okay. All right. Let's look at 9. All right. Again, I see a cotangent. I see a secant. I'm going to get in terms of sine and cosine. So I'm going to make this 1 over cosine of theta over. So the cosine of pi halves minus theta, so this is the cosine of the complement of theta. Well, the cosine of the complement is equal to just the sine of the regular angle minus sine over cosine. All right, and I want cotangent. Well, I don't want cotangent. Cotangent doesn't really help me, I like things in terms of cosine and sine. So cotangent is cosine over sine, because it's reciprocal of tangent. Okay, so here, fraction and fraction, we don't like that. So, thinking about what this is 1 over cosine times 1 over sine, because the reciprocal of sine is 1 over sine. So really, this is 1 over cosine theta sine theta minus sine theta cosine theta. Okay, well again, we need a common denominator. So this is cosine sine, and this is just cosine, so I need to multiply this by sine over sine. So I'm left with 1 over cosine theta sine theta minus sine squared theta over cosine theta sine theta. All right, so again, bring it over. So 1 minus sine squared theta over cosine theta sine theta. All right, now remember, you cannot cancel out the signs, okay, but we can convert this to something. So 1 minus sine squared, well, that's equal to cosine squared over cosine theta sine theta. And now is when I can cancel out a cosine to end up being cosine of theta over sine of theta. And that is exactly what I wanted. All right, so we're cruising right along. Okay, here we go. This side looks like a jumbled mess, so let's attack this. All right, so here I get sine squared x minus 2 root 3 sine x plus 3. All right, so this looks ugly, but I have a squared, I have a power to the 1, and I have no sign. So what that tells me is this is a trinomial that can be factored. Okay, so the only way to get sine squared is sine x, sine x. Okay, now 3, normally I would say 1 times 3 equals 3, right? But there's this root 3. So I also know that root 3 times root 3 equals 3. So I'm going to make these root 3's. Okay, because then you have -2 root 3. So the only way to get two root 3's together that are negative is if they are both minus. All right, so there's a top factored out, and I also can see in the bottom that I have a sine to the third and a sine squared, so they both have two signs in them. So I can make this sine squared x times sine x minus root 3. Hey, and I can cancel out one of those. And here's sine x minus root 3 over sine squared x. And that is exactly what they wanted me to step. All right. Well, that one wasn't even that bad. It just looked ugly. Okay, so sometimes looks can be deceiving a little bit. All right, so let's take a little break from our trig proofs and let's do some sum and difference. So here we have the tangent of 375 degrees. All right, so I'm actually going to get this to a coterminal angle. So I'm actually going to change this so I can have the tangent of 15 degrees. Okay, just because to me it's a little easier to figure out what adds to 15 than what adds or subtracts to 375. Okay, and just by taking away 360 is how I can get that coterminal angle of 15 degrees. So, okay, so now let's tangent of 15 degrees. Well, I can make that the tangent of 45 degrees minus 30 degrees. So now I just need this difference formula, so I get tan of 45 minus tan of 30 all over 1 plus tan 45 tan 30. Okay, so this is root 2 over 2 minus tan of 30 degrees is root 3 over 3. Ooh, I'm sorry, the tan of 45 degrees is 1. What am I doing? We're going to make that a giant 1. All right, it is 1. 1 plus, so here we have 1 plus basically root 3 over 3. Okay, so just because I'm running out of room a little bit, so common denominator, I'm going to make this 3 minus root 3 over 3. Common denominator here, I'm going to make this 3 plus root 3 over 3. Okay, simplifying that out gets me 3 minus root 3 over 3 plus root 3. And now I'm going to multiply by the conjugate to rationalize it. And I am going to get 3 times 3 is 9 plus, or I'm sorry, minus root 3, because there's a minus sign in here, minus root 3 times root 3, which is 3. So 9 minus 3 is 6 in the denominator. 3 times 3 is 9 minus 3, so I'm going to end up getting 6 minus 2 root 3 on the top, and both these can be divided by 2, so I'm left with 3 minus root 3 over 3. I'm going to divide everything by 2, so over 3, and that is my final answer. Okay, right? Didn't royally F that up? Don't believe so. Okay, so sine of pi 12ths. So again, I'm going to do another difference formula. So sine of pi 12ths, well, that's the same as the sine of 4 pi 12ths minus 3 pi 12ths. Pi 12ths is, so this is going to be pi, or 4 pi 12ths is the same as pi thirds times sine of pi fourths. Oops, I'm sorry, cosine of pi fourths. not doing well at the moment, minus sine of pi fourths cosine of pi over 3. All right, sine of pi over 3 is root 3 over 2 times root 2 over 2 minus root 2 over 2 times 1/2. So this is root 6 over 4 minus root 2 over 4. And we just combine this into one fraction, root 3 minus root 6 minus root 2 over 4. And that is my answer. All right, so here we get a cosine of negative 11 pi 12. So there's, again, several ways we could do this. I'm going to approach it as a sum problem. So cosine of negative 11 pi 12ths is the same as the cosine of negative 9 pi 12ths plus negative 2 pi 12ths. All right? Because it won't really matter in the end of it because cosine's an even function. So cosine sum formula, I'm doing cosine of 9 pi 12ths is negative 3 pi fourths times the cosine of negative pi 6 minus the sine of negative 3 pi fourths times the sine of negative pi over 6. Okay, so cosine of negative 3 pi fourths is negative root 2 over 2. The cosine of negative pi 6 is root 3 over 2 minus the sine of negative 3 pi fourths is negative root 2 over 2, and the sine of negative pi 6 is negative 1/2. Okay, so now we're at negative root 6 over 4 minus, here we have root 2 over 4. So it looks like I have negative root 6 minus root 2 over 4 is my answer for that problem. All right, nice. Here we go. All right, question 14. So I was unable to get this to copy over, so we're going to do this kind of the old-fashioned way of just looking at it. So here we have the tangent is 20 over 21, and my alpha is between 0 and pi over 2, and the sine of beta is 3 over 5. Okay, so what we really need to do here is think about, we have two triangles. Okay, so, sorry. What is happening? I need to go to my little, there we go. Okay. All right, so we have basically triangle alpha, okay, and its tangent was 20 over 21. So that would mean the opposite side is 20, it's 21. And it's, I know it's in the first quadrant because it said it was between 0 and pi over 2. Okay, so 20 and 21. All right, great, because then we just need to figure out what the hypotenuse was. And now we have our other triangle, and I already forgot what quadrant I'm in. And so let's, here, I am also in the first quadrant. Okay, so they're both in the first quadrant. And just quickly write down what it is that I'm finding. Sine of 2 beta, tangent alpha plus beta, cosine of alpha minus beta, and cosecant of alpha plus beta. Okay, sorry about that. Okay. Okay, so again, we have triangle 1. Here's alpha. I got 20 over 21. Okay, so that would mean that 20 squared plus 21 squared would equal c squared. And 20 squared plus 21 squared is 841. Second square root, second answer is 29. All right, so c equals 29 in that one. And then we have triangle number 2. Okay, our beta, where the sine was 3/5, that would mean this side is 4. Awesome. Okay, so now the first part A wants the sine of 2 beta. So beta means we want this guy here. Now we plug it into our sine formula, so that's 2 times the sine of beta times the cosine of beta. So this would be 2 times the sine of beta they gave me was 3/5. The cosine of beta is 4/5. So this is 2 times 3 times 4. 3 times 4, this is 24. 5 times 5 is 25. So it's 24/25. Okay. All right, so it's just using our formulas. So the second one was tangent of alpha plus beta. Okay, so that equals tan alpha plus tan beta over 1 minus tan alpha tan beta. Okay, so the tangent of alpha is 20 over 21. And I'm going to add that with my tangent of beta, which was 3/4. And I'm going to put that all over 1 minus 20/21 times 3/4. And then it's just a big, big, ugly mess of fractions. So we have to find something that both 21 and 4 go into, and let's, the easiest thing might just be to multiply them. So it's 84 all over, so that's 80 plus 3 times 21 is 63. Jeez. So 80 plus 63 is 143 over 84 all over. This is going to be 1 minus 60 over 84. So here I get 143 over 84 over, this should be 84 over 84. So 84 minus 60 is 24 over 84. And that simplifies down to 143 over 24 is my answer for that triangle. It's just a lot of fun with fractions. All right, so then what's the cosine of alpha minus beta? Okay, so I'm not going to write up the formula again, just to save time. So this would be cosine of alpha. So the cosine of alpha is 21 over 29 times the cosine of beta, which is 4/5, plus the sine of alpha 20/21 times the sine of beta, which was 3/5. Awesome. None of that can cancel, so I get 84 over 29 times 5 is 145, plus, this is, I can simplify this out, so I get 7 here, and I get 4 here, and 1, so this is going to end up being plus 4 over 7. And then we get another little fun fraction that we need to come together. So I'll let you kind of do that. Oh, yeah, what the hell? 10,015 or 1,015. So 84 times 7. This is 588 plus 4 times 145 is 580 over 1015, and we're left with 1,168. Yep. 1,000. I'm gonna rewrite this. 1,168 over 1,105. Okay, there's your giant fraction. Most likely on your test you would get much nicer numbers. Okay, and then cosecant of alpha plus beta. Cosecant is just 1 over sine of alpha plus beta. So this is just 1 over sine of alpha, which is 20/29ths. Oh. Okay, I realized that I made a mistake in C that I didn't mean to do. Okay, 20/29ths times cosine of beta, which is 4 bits, plus sine of beta, which is 3/5, times the cosine of alpha, which is 21 over 29. Okay, which equals 1 over, this is 84 over 145, plus, this should be 63 over 145. So you should get 1 over 84 and 63 makes 147. 145ths, which equals 145 over 147. Oops, 7. And there's your answer. Okay, on this one, this was totally effed up, and that should have been a 9. 20 over 29 is that, so this should have been 145, and 20 times 3 is 60. And so let's, I haven't actually figured out ever how to use the eraser on this. This, you should have gotten 144 over 145, and that is the answer for C. My fault. Okay, well, that was a mess. All right, 15. So we're just going to kind of do 15, and I'll do 1 of 16, and then we'll kind of be done. So 15, we have this crazy little sign problem, and I'm actually just going to do it on this. Cancel. Can I pen on this? I think I can. That's kind of annoying. Word is terrible. Okay. Y is 14.33 sine of 0.5x minus 2.44 plus 60.79. Okay, so when we're on here, okay, and you do have your sine function, okay, so I'm just going to rewrite it out. So I have it 14.33 sine of 1.5x minus 2.44 plus 60.79. Okay, so all it wants you to do is just use the difference formula to simplify this out. Okay, So y equals 14.33 times, so then you have your sine function of sine of a, 1.5x, times the cosine of 2.44 minus the sine of 2.44 cosine of 1.5x plus 60.79. Okay, and this just becomes this giant decimal problem, which you would need your calculator for. Okay, because this cosine of 2.44, I don't know what that is unless I plug it into my calculator. Okay, so this ends up, the cosine of 2.44 ends up being negative 0.76 times the sine of 1.5x minus the sine of 2.44 is 0.64 cosine of 1.5x plus 60.79. All right, and that's just multiplying this through. So 14.33 times negative 0.76. This is, I get negative 10.89 sine of 1.5x minus 14.33 times 0.64 gives me 9.17 cosine of 1.5x plus 60.79. And that is your answer, because you can't do anything else from there. So that's your equation, just simplified using the sine difference formula. Okay, and the last one was 16. And 16, I believe, was talking about using, our difference formula to verify the identity sine x minus 3 halves. Okay, so 3 pi halves, I should say. All right, so these are all just using your sum formula, so x minus 3 pi halves. Well, so this would be the sine of x cosine of 3 pi halves minus the sine of 3 pi halves times the cosine of x. So the cosine of 3 pi halves is 0 minus the sine of this is negative 1 cosine of x. So this ends up just being 1 times the cosine of x, or the cosine of x, because this is basically a co-function angle, or identity, okay? Because 3 pi halves is 270 degrees, so if I subtract it from there, it gives me my negative co-function identity, and cosine is an even function, so it ends up being just cosine of x. So you follow the same process on the rest of 16. All right, so hope that helped. Sorry for a little delay and a couple mistakes I made. It is Sunday evening and my brain doesn't work. So definitely ask your teacher over the next couple of days if you need extra help, and good luck on the